first one here. What is the dimension and unit of U? So, 1A here. Oops. Okay. 1A. So here we know that U equals D over T. So the dimension of U is equal to the dimension of D over T, which is the dimension of D over the dimension of T. In this case, D, we're told, has a dimension of length, and T has a dimension of time. So the answer is length per time. And as such, the units would be then meters per second. Okay. B equals U plus AT. So, whatever the units are on U, it must be the same as AT, because we're adding them together, and we can only add them together if the units are the same. So whatever units we have for U, we must have them for AT, and when they add together, they must be the same units we had a moment ago, which must match the units for V. So basically all these three things must have the same units, and we already know the answer for U, so the answer for V is the same as the previous one. The dimension is length per time, and the units is meters per second. Okay, C, we have A. From the previous one, we can see that AT is the same dimension as U, and the same dimension as V, which is length per time. So that means the dimension of A times the dimension of T must equal length per time. Well, this is time. So that means A is length per time over time, which is another per time, length per time squared. The unit is meters per second squared then for that one. Okay, D, F equals MA, so the dimension for F is the same as MA, which is the same as dimension of M by dimension of A. So that dimension is mass, and that dimension is length per time squared from the previous question. So the units would be then kilogram meters per second squared. E, let's see, so we have F equals G M1 M2 over D squared. So if we rearrange that, we get G equals F D squared over M1 M2. Just bring the D squared up and the M's down, leaving me with just my G. And the dimension of G is the dimension of all of this. And we have the F from the previous one, it's mass length per time squared. The D, we're told, is length squared. And the mass here is M squared. Okay, so that cancels the square. The length and the length squared can make a length cubed. We have a mass underneath per mass, and then we have a per time squared then. Okay, that's fine, that cancels that. Okay, so that is units of meter cubed per kilogram per second squared. And that's the first question.